AI is making amazing progress, and today is already making lives better for hundreds of millions of people. I wanted to create a few videos to share with you some of the latest exciting trends in AI, as well as maybe give a little bit of advice about how you yourself might be able to apply AI or how your organization might be able to do so. In this first video, I want to share with you some thoughts on how scale is driving the latest progress in AI and machine learning, and specifically in deep learning. The latest hottest trend in AI is deep learning, also known as neural networks. I've shown an example of one here where, here you would have some input, such as maybe an image or an email, and then all of these simulated neurons process the input until eventually you get an output here, such as recognizing someone's face or deciding if a piece of email is spam, and so on. So many of the basic ideas in deep learning or in neural networks have been around for many decades, but it's only in the last few years that these ideas have been taking off. Why is that? At the risk of oversimplifying slightly, I want to present one picture that tries to explain the rise of deep learning. There are a lot of reasons behind the recent rise of deep learning, including a lot of great researchers all around the world creating lots of algorithmic and other innovations. But if I had to pick just one idea that I think explains the rise of deep learning the most, then this would be it. So I have here a plot that I'm going to fill in, and on the x-axis I'm going to plot the amount of data that we have for a problem, and on the vertical axis I'm going to plot the performance on some unspecified scale, but so some sense of the performance of how well our algorithm is doing on some task. If you were to use a traditional learning algorithm, such as a support vector machine or logistic regression, then as the amount of data increases, the performance of the learning algorithm might look like this, in which it goes up as you increase the amount of data, but then pretty rapidly, nearly plateaus off. So it's as if, even as you increase the amount of data, the learning algorithm doesn't quite know what to do with the more and more data you might be able to give to it. Well, how about deep learning or a neural network? If you train a small neural network, that is with a relatively small number of simulated neurons, then the performance maybe will look like this, in which, as you increase this amount of data, its performance gets better, but it still plateaus off after a while and doesn't get that much better with more data. But one of the exciting things about neural networks is that if you then train a somewhat larger neural network, maybe then the performance starts to get better and better, even as you increase the amount of data. And so that's maybe how well you do if you train a medium-sized neural network. And if you train a very large neural network, then your performance might look like this, in which the performance just keeps getting better and better as you increase the amount of data. So I think what's happened over the last few decades as humanity spent more and more time on digital devices is that the amount of data we had for a lot of problems increased. So we moved to the right of this curve, and for a lot of problems, not a lot, but for many problems, we're now in a regime of having a lot of data. With the traditional learning algorithms, the performance of still wasn't that good, even with a lot of data. But as we build huge neural networks, we find that these neural networks are better able to take advantage of the huge amount of data that we now have access to. And so what we see today is that for many problems, not all, but for many problems, in order to get great performance, you need to first train a very large neural network so that you're on the green curve, and second, make sure that you have a lot of data so you can hit a performance point that's up there. In order to make sure that you can build a large enough neural network and also process a huge amount of data, this is why also a lot of the bleeding edge research in machine learning or deep learning is switching to HPC or high performance computing, in order to have the scale needed to process a huge amounts of data and on very, very large neural networks. So that's it, a single picture that tries to explain how scale is helping to drive the rise of deep learning. And this is, of course, complemented by a lot of algorithmic innovation, by a lot of amazing researchers as well. Before I wrap up, just to mention, turns out today that one of the most reliable formulas, one of the most reliable ways to get good performance on a machine learning problem is this maybe relatively simple, well, it seems simple but hard to implement, formula of having lots of data and training a huge model. And if you're able to do both of these things, often that's a reliable formula for getting better performance on your task as well. That's it for this video. In the future, I hope to keep on creating other videos to share, little ideas in AI and machine learning and deep learning. And I would love your feedback. So whichever website you're watching this video on, I hope that you also post your comments below and share your feedback with me.